The research methodology encompasses the strategy employed to achieve research objectives through one or more methods. Three broadly generic research strategies are identified: experiments through variable manipulation, surveys and interviews through information collection, and case studies through intensive knowledge of a single case or multiple related cases. A research methodology section also requires the definition of two major dimensions: research philosophy and reasoning. Research philosophy, or paradigm, refers to the set of common beliefs and agreements shared among scientists regarding problem understanding and addressing. This involves philosophical concepts such as ontology, which questions the nature of existence, and epistemology, which deals with the process of knowing and what constitutes valid knowledge. Three main research paradigms are identified: positivism, constructivism, and pragmatism. Positivism assumes a single reality or truth that can be measured through proper tools, often employing quantitative methods. Constructivism posits that reality is created by individuals or groups, requiring qualitative methods to interpret reality. Pragmatism views reality as constantly renegotiated in light of new situations, often combining quantitative and qualitative methods. Research reasoning is also crucial, as technological change is often seen as driving social change. The amount and use of information in a society are considered crucial social features, influencing advancements in economic, political, and social systems. The philosophical underpinnings of this thesis are rooted in Darwinian evolution and technological change, suggesting that individuals must evolve with society to avoid being left behind. Table I summarizes the three research paradigms, outlining their ontological, epistemological perspectives, and corresponding methods. The table highlights the distinct characteristics of each paradigm, providing a framework for understanding the methodological strategies employed in research. By defining research philosophy and reasoning, researchers establish a foundation for their methodology, ensuring that their methods align with their research objectives and underlying assumptions. Here is a combined summary of pages 3 and 4 of the research paper. The concept of holism, hermeneutics, rational choice theory, and critical theory are essential in understanding the role of information access in a technologically advanced society. Holism highlights that shared information provides a society with more and better quality information than individual access. Hermeneutics emphasizes the importance of rules guiding information access, while rational choice theory suggests that agents balance the utility value of information against other commodity choices. Critical theory underscores how information access shapes a society, influencing its direction and services. In the context of research methodologies, two primary approaches are identified: deductive and inductive. Deductive research, commonly used in natural sciences, involves analyzing the current state of the art, identifying a problem, and formulating a hypothesis. In contrast, inductive research, predominantly used in social sciences, seeks to gain explanation or understanding through empirical observations without a priori hypothesis formulation. A comparison of these two methodologies is presented in Table 2, highlighting their differences in explanation, data, methods, and practices. Deductive research focuses on quantitative data, physical or statistical controls, and hypothesis testing, whereas inductive research emphasizes qualitative data, real-world research, and open-ended questions. The practices of deductive research involve testing or verifying theories, identifying variables, and relating variables, whereas inductive research involves positioning the researcher within the context, collecting participant-generated meanings, and focusing on a single concept or phenomenon. Additionally, research can be divided into two smaller groups, further emphasizing the distinction between deductive and inductive approaches. Understanding these research methodologies is crucial in guiding the development of telecommunications and computer systems, which are rooted in social scientific facts and driven by the beliefs and desires of society. Research in computer science can be categorized into basic and applied research. Basic research focuses on understanding a phenomenon to advance knowledge, whereas applied research aims to solve a practical problem based on an existing theoretical foundation. A mix of quantitative and qualitative data can also be used in some cases. Additionally, research can be classified as exploratory, explanatory, or descriptive. Exploratory research formulates problems and hypotheses using qualitative data, whereas explanatory research uses quantitative data to explain a phenomenon and predict future occurrences. Descriptive research, which can employ correlational, development design, observational, or survey methods, collects data to describe and characterize phenomena. Data can be divided into two major categories: quantitative and qualitative. Quantitative data is factual and used to study relationships between facts, providing conclusions based on the current state of the art. Qualitative data, on the other hand, is used to evaluate and theorize problems, focusing on the qualities of the investigated phenomena rather than their numeric measurement. Data can also be classified as primary, collected directly by the researcher, or secondary, collected by someone else. There are three main ways of collecting data: observation from nature or experiments, obtaining data from individuals or communities through interviews or surveys, and using historical data. For data to be considered good, it needs to be obtained from appropriate sources and in large quantities, with a broad, credible, and diverse consulted audience. However, collecting data through interviews or surveys raises concerns about subjectivity, manipulation, and reproducibility of results, as well as issues with respondent interpretation and data protection. In quantitative research design, a stepwise approach is employed, involving the following sequences. Here is the combined summary. In the methodology chapter of a computer science dissertation, it is essential to identify the research purpose, develop research questions or hypotheses, identify variables, and decide how to measure and analyze them. The researcher must also collect and analyze data, ensuring that ethical considerations are addressed throughout the process. These considerations include avoiding plagiarism, acknowledging others' work, and documenting results in a manner that allows other researchers to replicate them. In terms of research methodology, various paradigms and approaches can be employed, such as qualitative research, case study research, and grounded theory. Researchers must be aware of the philosophical underpinnings of their research, including ontology, epistemology, and methodology. This awareness is crucial in selecting the appropriate research design and methods. The references provided highlight the importance of understanding research methodology and its applications in various fields, including construction management, education, and sport management. Researchers must be familiar with the works of prominent scholars in the field, such as Robson, Yin, and Kuhn, among others. The guidelines for the methodology chapter emphasize the need for researchers to comply with ethical concerns, ensure the originality of their work, and acknowledge the contributions of others. By following these guidelines and being aware of the methodological and philosophical foundations of research, computer science researchers can ensure the validity and reliability of their findings. The authors provide a comprehensive guideline for the methodology chapter in computer science dissertations, emphasizing the significance of engagement and evaluation in qualitative inquiry. They draw upon established research in social measurement, ethics, and qualitative research to inform their approach. The methodology chapter is crucial in establishing the research design, data collection, and data analysis procedures. The authors highlight the importance of distinguishing between primary and secondary data collection, citing Hawks and Boas, 2005, work on this topic. Primary data collection involves original data collection, whereas secondary data collection involves analyzing existing data. In terms of data collection, the authors stress the need for ethical considerations, referencing McKee's, 2009, work on the ethics of Internet research. They also draw upon Mouthner's, 2002, and Oliver's, 2010, research on ethics in qualitative research and research ethics, respectively. Additionally, they cite Recker's, 2012, Guide to Scientific Research and Information Systems, which includes a chapter on ethical considerations in research. The authors provide a detailed outline for the methodology chapter, comprising 4 main sections: research design, data collection, data analysis, and ethical considerations. The research design section should outline the research approach, sampling strategy, and data collection procedures. The data collection section should describe the data collection methods, instruments, and procedures. The data analysis section should explain the data analysis techniques, including data preparation, data transformation, and data modeling. The authors emphasize the importance of transparency and rigor in the methodology chapter, ensuring that the research design, data collection, and data analysis procedures are clearly outlined and justified. They also highlight the need for researchers to address potential ethical concerns and limitations in their methodology.